Welcome back to one more session of Business Analytics. This is your favorite professor, Hari Rajagopalan, and I will talk about measures of dispersion in this session. Now, let's look at where we are. Remember that analytics can be split up into multiple modules. We have Descriptive Analytics, which is your first module, Predictive Analytics, which is your second module. The third is Prescriptive Analytics. Fourth, we will talk about Risk Analytics, and then we will decide on some decision-making tools. But today and this module which you're working on is bang on Descriptive Analytics. And to remind us on Descriptive Analytics, it basically takes historical data, helps us identify patterns and trends. We can do some exploratory data analysis. Remember in the last session, you talked about types of data, and that is so critical for us when we want to figure out what kind of statistical tests we're going to use. And now we talked about measures of central tendency, and in this session, we're going to talk about dispersion or variability and how we are going to measure that. So let's talk about dispersion or spread. Why do we need a measure for that when we have mean, median, and mode? We have percentiles. Why do we need this kind of measure for how the data is spread out? So let's take two groups of vendors, Group 1 and Group 2. Both of them say our average cost for services rendered is $5,000. Now, if this is all we know about the groups, we can assume that they are the same. But once you look at the numbers, you will see that these two groups are quite different. Group 1, all their quotes have been $5,000, whereas Group 2 varies from $3,000 all the way up to $7,000. So if you just look at the mean and the median, you're going to assume that these two groups are the same, and yet once you look at the data, you know that they are different. So we do need a measure to talk about spread or dispersion of data. And the reason is, while this is 5 numbers and it's easy to find out, and I've used an extreme example for you so you can see why it's different, when you have millions of tons of data, when you have lots of data, it's going to be difficult for you to it doesn't jump out that these two groups are the same or different. And therefore, you need some kind of way to measure that dispersion or spread. So the first measure we're going to talk about is the simplest measure, and that's called range. Range is simply maximum value in a group minus the minimum value. So for Group 1, that would be 0. Group 2, it is 7,000 minus 3,000, which is 4,000. Now this is a very, very simple, straightforward way of measuring how your data is spread out. Easy to calculate and easy to understand. But there are some problems in using range. First, you're going to use two extreme values. Remember that example with Jeff Bezos and Bill Gates? Now, if Group 1 did not have Jeff Bezos and Bill Gates, and Group 2 had Jeff Bezos and Bill Gates, just by having two people in one group, it's going to show that this is really different. Whereas the two groups might be the same and just two people might be the weird, what we call them as outliers. So there's a big disadvantage in using range. If you want to calculate range in Excel, you essentially use max, select the whole range, minus min, which gives you the maximum value and the minimum value, and you can calculate your range. The second measure of dispersion or spread or variability is called the Interquartile Range or IQR. Now remember, in the last lecture we talked about percentiles. So interquartile range is you can normally use Q3 or the 75th percentile and Q2, which is the 25th percentile, and you subtract the two. That contains about 50% of the data. 75 minus 25, that's about 50. And you'll see that group 1, it's still 0 because all the data points are the same. And in group 2, it's about 2,000. The advantage is it's a lot more robust compared to range, where you're not using the maximum and minimum value and therefore may not be influenced by outliers. So if you had Jeff Bezos and Bill Gates, who will be the largest, they'll be in the maximum 2, and if you have thousands of data points, you probably are not going to use their values. And so it's particularly useful when you have skewed distributions. Your disadvantage, you're still basing it on 2 values, and sometimes you might take multiple IQRs, so you don't always have to take Q3 and Q1, which is 50% of the data. You might want to take 97.5, the 97.5 percentile and 2.5 percentile, which covers 95% of the data. Now remember, the broader this range is, the higher the variability is going to be, because there is a higher chance that outliers might fall in there. Now in Microsoft Excel, you can calculate interquartile range by using the percentile .inc, that's inclusive, and you select the set of data, and then you put in the kth percentile. In this case, if you wanted a Q3, you put 0.75, and if you want Q2, you put 0.25. The array is the range here. We are using range and array interchangeably. The next measure of dispersion variability is important, used a lot, but it's not very intuitive and not very easy to explain. And that's called variance. Now, variance is the average squared difference of the values from the mean, or the squared difference from the mean. And that kind of makes it hard to explain what it is. Bear with me. We'll use variance, and then we'll talk about another measure called standard deviation, which is a lot more intuitive. In Excel, we can use equal to var.p or var.s. If you have a population value, then you use .p. If it's sample, you use .s. So the way you calculate variance is you take each value and subtract it from its mean, and that's the difference from the mean. Then this difference from the mean is squared. Each one of it is squared separately, and that gives you squared difference from the mean. And then when you add all these squared differences from the mean, that becomes sum of squared difference from the mean. Now if you divide the sum of squared difference from the mean, that gives you average squared difference from the mean. And that's what this is, average squared difference. So essentially you find the average for this. In this case it's 5,000. You take each value, subtract it from 5,000, 3,000 minus 5,000, 4,000 minus 5,000, and so on. You square that difference for each one. In this case you'll have 5 squared difference from the means. You add it all up, and then you divide it. If it's a population value, you divide it by 5. If it's a sample, you have to use number of data points minus 1. And this is mathematically shown that sample, it's important to do that. I won't get into the details on why you have to do that. I'll just take it that if you have sample values, you have to use number of data points minus 1. If you use population values, you just have to divide it by the number of data points to get the average squared difference from the mean. So in group 1, it's $0 squared. Remember, this is a squared difference, whereas in group 2, it's about $2 million squared. And this is what causes the problem with variance. What is dollars squared? It doesn't mean anything. So the advantage is We have a lot of statistical tests that use it. Higher values indicate higher dispersion or variance. Disadvantages, it doesn't make any intuitive sense. So to make intuitive sense, we use a different measure. It's called standard deviation. Standard deviation is nothing but the square root of variance. So you follow the same steps you took in variance, and then you find the square root of it to get the average difference of the values from the mean. So standard deviation is simply the average distance from the mean. So in Excel, you can use stdev.p or stdev.s, depending on whether this data is an entire population or a sample. And here we have the manual calculations. You essentially find the variance and then take the square root of that number. So here group 2 has, now group 1 standard deviation is $0. Group 2 is $1,414.21, and this makes intuitive sense. So we're saying on average, group 1 and group 2 have a $5,000 as the average, that is your mid value. But this has $0 standard deviation, which means you can expect each one of those values to be 5,000. Whereas on average, this group is going to be off from this 5,000 by 1,414. Remember, when you use average, it's sometimes more, sometimes less. So you can be off by more than 1,414 or less than 1,414, but this is the average amount you're going to be off. So advantage is that it uses its original units like dollars, so it makes sense. You use all the data you have to calculate it. The disadvantage is it is hard to use for skewed distributions. So which is best, range, interquartile range, or standard deviation? You'll notice that I've taken variance out of this list. And that's because standard deviation pretty much gives the same answer as variance. It's just the square root of variance. And variance is hard to explain. It makes sense sometimes to use variance in the calculations because you can add the variances up to get a pooled variance. We'll talk about that much later. But standard deviation gives you a better answer which you can explain to people. Now, if sample size is very small and you don't have enough data, then range is okay to use, especially if you're comparing the same sample size. Now remember, still a single outlier can throw range off completely. If you have skewed distributions, we know from our past lecture that median is a better central tendency and median pairs well with interquartile range. Might be a good idea to use multiple interquartile range to get a feel for the data. Now, if it's a normally distributed data or quite symmetric, the mean and standard deviation is the gold standard. It's very common, and you can also use percentile-based ranges if you need to. So with this, we finish measures of variance. Now remember that whenever you talk about data or data analysis, always insist that you have a measure of central tendency to represent the data, but you also are given some measure of dispersion or measure of variance so you understand how the data is spread.